Hello, I'm Ed Larson. I'm the team leader for Tampa Deep Sea Explorers. This is our DeepSix team, which is entered in the OpenWorks Challenge Hackathon 2017. The challenge that we chose was the Bounty Hunter, which in this scenario, there is a missing ship somewhere in the Yellow Sea around South Korea, and pirate activity is suspected, and we were to use provided data and satellite imaging to hopefully locate the ship and determine its location and outcome. We were provided some preliminary data. The ship had a transponder which was in operation for approximately 10 hours and returned data approximately once every hour. This track shows the path that the ship took along its heading and its last known position in the Yellow Sea. The approach that we chose, we were intended to write a program using open source modules for artificial intelligence, deep learning, and analysis to solve this problem. This flowchart illustrates our approach to the algorithm that we were to use. The first part of the algorithm is very simple. We simply assume that the ship has maintained its present course and heading a certain distance. In this case, the last known velocity was 19 knots per hour. So we came out here 19 nautical miles. The search area's diameter is the same distance, 19 nautical miles, and we searched that area. This eliminates the possibility that the transponder failed, that they're slightly off course or they're slightly behind schedule. If this preliminary search fails, then we pick a path on the right and left, and we determine a new center point for these search areas, and then we search these as well. If this search fails, then we take into account weather conditions, regional factors such as pirate activity, terrorism, and natural disasters to widen the search. So this first part of the algorithm I've described. This is the preliminary search on the center line. This is the right and left search if that fails. If this fails, then we take into account the regional factors, recalculate speed, recalculate based on the environmental factors, and then determine a new search area. And we continue in this mode until we locate the ship or exhaust the data. This is an illustration of wind data which we have collected, and the animation shows what the prevailing winds were in that area. One of our members worked on that. Another one of our members worked on the cloudless algorithm, which was designed to identify the frames where clouds existed and the areas where the seas were obscured by clouds, and so the search would be unsuccessful there and we could ignore those areas. In addition to cloudless, another one of our members worked on object recognition using OpenCV to determine the basic image of the ship and try to identify it in the satellite imaging. We were unable to finish our program, but we followed the same algorithm and search criteria to locate what we feel is the final location of the ship. This illustrates the known path of the ship, the first center point of our search area, 19 nautical miles from the last known position, which we searched. When this failed, we expanded our search area, right and left, and then moved down what we thought was a likely path of the ship. In this case, the ship was located at 34.064 latitude, 126.770 longitude, and that was in a frame here just south of the peninsula. This is an image of the ship. And this is the frame where we found it, 201701-012-701-1005. We estimate that the speed of this ship was 19 knots with a current of 2 knots behind it. And it appears here, so we have an area that we can go to locate the ship. Thank you for your attention. This is a picture of some of our members. We're called DeepSix. However, there were 8 members that worked on this project. Several of them were remote. But thank you very much.